All right, good morning. How is everyone today? Awesome. Tired, I can relate. Well, summer is coming in just like 40 some weeks, and we can get some sleep then, maybe. That's my plan. All right, so, bunch of things to go over today. So, first thing I want to do, I've posted your first one-day program. So let's talk about the one-day programs, which I've mentioned, but let's go into the details of them. Yeah, I hear you. I didn't actually sleep this summer either. Um, so let's hop over to Canvas. So come down in Canvas one-day programs. There's a link to a video that you can go to. It's about a 6-minute video, I think, that summarizes what we're going to go over right now, which is how you use this automated assessment system. So one-day programs are designed to be, 24-hour assignments that should only take you a few minutes if you're up to speed and you actually understand everything that we've been doing up to that point. If, however, something's not quite lined up right in your understanding, these can take you longer. Okay, it's not unusual, especially in the early ODPs, for people to spend a few hours trying to get this one-day program to work. But it's important to spend that time, right? If you completely understand, how to compile a C program, for example, to print out "Hello World," it will take you about 5 minutes to do ODP 401. But if you think you understand that, but you're kind of rusty on it, and there were a few things you never quite got, and you need some practice on it, it might take you a long time to do ODP 401. Okay? But the goal is that, once you're up to speed and you can follow each lecture and get what's being presented new in each lecture, right? Your understanding should go along, should increase along with the increase in difficulty of the ODPs, and eventually you get to this point where we go over, topic X, and then you get an ODP on topic X, and it takes you 5 or 10 minutes to do. Okay, so the early ones might take you a long time, but it will get better over time. And by the end of the course and by the end of the year, if you can take one of these ODPs and knock it out in a few minutes, it tells you that you have a really solid understanding of whatever it is that we've been discussing in class. And that's what you're going to build on in subsequent classes and, when you transfer to university and so on and so forth. So, so the ODPs are normally 24-hour assignments. Since this is the first ODP, I'm actually giving you 2 days to do it so that you can try it today, right, or right now if you like. And then if you can't get it to work, you can ask questions about it in class on Friday, okay? And then hopefully you go from class Friday, you get it to work, and you're done. Normally there'll be 24-hour turnaround, so normally this would be due tomorrow at 8. But you've got until Saturday, okay? But you've got to try it today, because if you don't try it until Friday and it's not working, I'm probably not going to be able to help you, right? Because we'll already have had class. So you want to try this today, even though it's not due for 2 days. All right, so let's take a look at the assignment. So your first ODP program, which you have 2 days for, basically you're writing a "Hello World," okay? Kernighan and Ritchie in their original C book used the notion of writing a program that prints "Hello World" as kind of the quintessential first program you might write when you're trying to learn a language. And so their first sample C program in their book is something that prints out "Hello World." And we're going to do this as a class, shortly. I'm going to actually write this program for you. You can see the code. You can copy the code if you like. The goal here is to, be able to enter the code in an editor, compile it, execute it, run it through the assessment system. Okay? So you should write a C program. I want you to name your program ODP 401.C. This is important because there are a few names that if you give it, like test, for example, it won't assess properly. Because if you just type test, you're not going to end up running your program. You're going to be using a built-in command called test. So I'm going to say name your program odp401.c. It should print a single line that says hello world, uppercase H, uppercase W, one space in between hello and world, and then a new line at the end. Okay, it has to print out exactly that. All of these ODPs, they have to follow the specification exactly. And this is the other purpose of the ODPs, is to get really good at reading problem specs. Okay, it's pretty common to, you know, read instructions for something, and, you know, you're building a piece of IKEA furniture. It says, you know, attach the legs to the tabletop, right? Well, maybe you attach the sliders to the drawer first, right? It still works. Medicine is surprisingly forgiving, you know. I had some surgery and some things went wrong in the procedure and I survived, right? But computers, there's so little room for mistake, right? You can write 100,000 lines of code, and at one point you put in a period instead of a comma, and suddenly you have a catastrophic failure in some system. Okay, so it's really important in computer science to try to follow a specification as exactly as possible. And this is, you know, also preparation for the university experience, because a lot of times teachers will use automated systems to grade assignments, and if there's something slightly off, if you have one extra line of output, you might end up with a 0 on an assignment that works perfectly otherwise. Okay, so we're gonna use this to also improve our ability to understand specs and to know when we should ask for clarification, right? Because I'm not going to be able to write perfect specifications every time. There might be ambiguities, and you got to know when you need to come to the teacher and say, hey, I don't understand what we're supposed to do here. Is it this or that? All right. So you're going to write your program, odp401.c. You're going to compile it into an executable called odp401, and then you're going to ask the system to assess it for you. And there's a command on the Linux server called assess. And you use it as follows: assess space the name of the executable program that you're testing. Okay, this is the program name that you would type in to run your program at the command line, space, and then the name of the source code program, odp401.c, the thing that you edited that contains your actual C code or your bash script or whatever it is we're working on. All right, and once you run assess, it will bring up a little window for you with some options, and we'll go through that in a minute, and you use that to get your grade. Okay, on the Linux server, there's also a file called /temp/readme401, which will give you more details, including how to actually use the assessment command. And then once more, there's a link to a video that takes you through all of the steps. All right, so plenty of pathways in here to figuring out how to do all this. But let's go ahead and do this ourselves. So I'm going to log into the server as a test user. And first thing I'm going to do is I'm going to look at that README. So it said there's a README under /temp/readme401. Okay, we can use the command cat to look at the contents of a file. And I'm going to say cat/temp/readme-401. And it gives me this output. So odp401 echo hello world to standard out, write a C program, name this, which outputs one line of text, hello world. That's all the program should do, print hello world without quotation marks, right, followed by a new line. Compile your program into an executable, submit it for grading using the assess command. Assess will give you a prompt, type in the command uppercase G to say I want to submit this for grading. Once you're done, hit an X to enter, to exit the system. Okay, you can submit your code as many times as you like for grading. It's all automated. It remembers every submission that you make, and it records your source code, and it records the grade, but it's the last grade that it gives you which will be recorded in Canvas. So if you try this, 500 times, and the 500th time you get 10 out of 10, that's when you want to stop. Okay? If for some reason you go back and you make a change and you try that again and it gives you 0 out of 10 and you stop there, you're going to get a 0 out of 10 recorded. All right. So 2 notes. Second note is what I just said. It's the last attempt that's recorded. First note, again, make sure you follow specification exactly. All right. So let's try this. Let's make an ODP 401.c. So I'll include standard IO.h. I'll make my main program. And I'll print out hello world. And I'll compile it. Now I always recommend that that you run your program first before you try to assess it, because the assessment system won't tell you what went wrong. It's just going to give you a cold number. In this case, there's one problem, so it's going to be 0 out of 10 or 10 out of 10. So run your program first, make sure it works. Don't trust the assessment system to help you debug your program. So I'm going to go ahead and run my program, and somebody's already ahead of me in chat, but that's okay. I'm going to run my program, and I look, yep, prints out hello world, that's good. I'm going to go ahead and assess it. So I'm going to say assess ODP 401, ODP 401.c. So welcome to the automated assessment system. Here's my 3 commands that I have. And then down here, it will say you're about to assess your code for, and it will tell you a 1-line synopsis of what your program should do. Okay, make sure that this is what you think it's supposed to be. If I'm writing code for ODP 401 and this says you're about to assess your code for ODP 402, write a program that calculates pi to the last digit, right? Stop what you're doing. Because if I submit my code for ODP 401 but it's assessing ODP 402, it's really not going to work. Alright? Or if I think I'm doing ODP 402 and this says I'm doing ODP 401, stop what you're doing. Because if I submit different code, I'm going to get a 0, and that's going to replace, you know, my previous best score, my last score that I got for 401. So always double check, make sure this is what you think it is. Alright? So I'm confident I'm assessing the right program. I'm going to go ahead and submit it. I'm going to use an uppercase G command. And unfortunately, it's going to give me 0 out of 10. Alright, so something is wrong. Right, and if you read the chats, you can see what's wrong, right? I made something lowercase that should have been uppercase. But here's the thing, you're going to be tempted at this point to send me an email and say, you know, I wrote the program perfectly, I assessed it, I got 0 out of 10. What's wrong? Okay, I have no idea what's wrong. I don't know what you've just done. So my recommendation, I'm going to hit X to get out of here. My recommendation is first run your program again and go back to the assignment. And what is my program supposed to do? It's supposed to print a single line that says hello world, pay attention to uppercase, lowercase. And yeah, it prints out hello world. Okay, it may be one of these things where you can stare at this 100 times and you're not going to notice that the world is lowercase instead of uppercase. Right? Sometimes you need to take a break. I used to tell people go out and take a walk. Well, you can still do that. There's no smoke today. Go out and take a walk, or listen to some music. Come back to this. Okay? This is one reason you don't want to be doing this at 7:45 the morning that it's due at 8. Okay? So come back to this eventually and say, oh, that's supposed to be in uppercase. Okay, so go ahead and VI it and change that to an uppercase W, recompile it, let's reassess it, let's use the grade command. Hey, I got 10 out of 10, I'm done, right? I can go take a nap or something. Alright, so that's all you got to do to assess. Alright, questions about that? All right, so right, that's the only code that you need for ODP 401. Right, it's 5 lines of code, and you're welcome to put that in verbatim. because you know, this is not really an exercise in tense C programming. This is an exercise in learning how to use the assessment system. Okay, so if you want to just take the code from there, that's absolutely fine. And you know, there's different ways that we could do this. Right, if I write my code like this, it's going to work perfectly fine too. Right, as long as it's doing the correct thing. Now these early ODPs were just generating output, and so they need to be very, very particular about formatting and so on. But as we move forward, we'll start making ODPs that are actually functions, and then it will be a little less picky about what exactly we have to do. But you know, if you do something as benign as put in extra space at the end, right, that'll bring your grade back down to a 0. All right, so this brings up another topic that I started to talk about in a video I posted, which is getting help on these ODPs. What if you put in an ASCII escape sequence? Like if you turn it into boldface or something like that, that will also not assess with 10 out of 10. Because that's actually just different output going to standard out. So let's say you do something like this. All right. I'm trying to assess my so I'm putting myself in the mindset of a student working late at night trying to get this done. So I'm assessing my program. I'm getting 0 out of 10, and I don't know what's going on, right? And you know, I'm pretty sure I got the code entered in right, but when I try to assess, I get 0 out of 10. And so I send an email to my teacher and I say, hey, I think something's wrong with your assessment system. My code looks perfect, but it's not assessing correctly. What's wrong? I can't tell you what's wrong, okay? So pre-COVID, right, you would come into my office, you would open up your laptop, you would go through all these steps, and we would look at it together, and I would hopefully be able to tell you, okay, take a look at such and such, or think about this, or go back and try that. That's harder to do online. So here's what I need you to do, okay? I need you to show me how you are going through the assessment process. So first thing to do is, let's clear my screen so I know where I'm starting all of this, right? So let's show me the contents of your program, ODP401.c. Show me the date. That's always a good idea, okay? Just use the date command. Now I know what the program is you're working with. I know what the date command is. Show me how you're compiling it. Show me how you're assessing it. Show me the result of assessing. Okay, now go back here, grab all of this stuff. And again, like on most terminals, if you just select your text, it pastes it, it copies it onto your clipboard, right? And now go into your favorite mailer, which I'll just bring up an empty window here for kicks. But go into your favorite mailer, right, and just paste it. And send that to me, okay? Don't do screenshots. Screenshots do not work. They end up being huge. If you mistakenly send it to Canvas, I can't read it. They don't capture the whole screen. Sending me 5 screenshots is not going to get a lot of satisfaction. Just copy the text from your terminal session, paste it into a plain email message, and send it to me. Okay? And now I can go through this and I can look at exactly what you did, and I can see exactly what went wrong. Yes, your ODP401.c looks perfect. Yes, you used the assess command perfectly correctly, but guess what? When you compiled it, you did not build an executable called ODP401. You compiled this into something called a.out. And sometime earlier in the day, you apparently compiled it into an ODP401, but that old program is what's being assessed here. Okay? I can't figure that out if all I see is your code, or if all I see is your assess output. So the more information you can give me, the better the chance I'll be able to point you in a direction for where to look to figure out what's going on. Okay, hopefully that makes sense. So then you fix your compile line. You reassess, you grade, you got your 10 out of 10. All right, so work on that today. Try to get it assessed before class time tomorrow. Let me know if you're having problems, and if I don't get a hold of you, you can ask in class tomorrow. Let's see. Questions on chat. Yeah, I am a spaces guy. Will this put the grade in Canvas too? No. So assess does not automatically upload the grade. It dumps it into a file, and then I run a script which will take that and push it up to Canvas. So typically it might be a few days, maybe once a week, I upload all of the assessment grades, and then they all suddenly pop up in Canvas. All right, let me hop back into my environment. So, let's talk about customizing bash. So lots of ways to customize your bash environment. One thing you definitely want to know about is a file called .bashrc. All right, so there's a few things here. If I go into my home directory and I just do an ls, I see a few files like pa1.c. I see a bunch of directories, and that's it. Okay. There's actually more files in here than I'm seeing. There are things called hidden files, and a hidden file is a file that begins with a period. So let's make a .hidden file. Okay, and if I look, I don't see that showing up when I say ls. It's still there, right? But if I want to see it using ls, I can say ls-a, and now there's my hidden file. There's nothing special about a hidden file. It's not inherently different from any other file. ls is written so that it just doesn't show file names that begin with a period unless you put in a switch that says show me those hidden files. But it's not inherently different. It's as good as any other file, right? I could make a C program and have it start with a period, and I could compile it and execute it and so on and so forth. It's just a convention that the ls program uses. And it's a way that we can have lots of files that need to be in our directory, but we don't want to see them every time that we say ls. But they work just like any other file. All right, so one reason we use this is because we like to have files around that store information for us. Okay, information about our environment, information about what we're doing, and so on and so forth. For example, here's a file called .bash_history. That's where the history of all of my commands are stored. And someone pointed out, yeah, LA is the same as ls-a, if you have it set up that way. But I think I have that removed. Yeah. But normally by default, LA is a shortcut for ls-a. All right, so so we have useful files that we don't want to see on a daily basis, but that we need to have existing anyway. So for example, I have a file called .plan and I have a file called .project, and there's a utility called finger, which you can use to find information about people. So if I say finger Nick, it will show you my project and my plan. Okay, all it's doing is reading from these files in my home directory called .project and .plan. So what you used to do, you were working with other people, right? You could keep these .plan, .project files and people could see what you were working on. So collaboration. Alright, so there's one file in particular called .bashrc. So .bashrc is a file which is executed every time that you start a bash shell, every time that you log in, basically. So let's take a look at bashrc. And you have a bashrc sitting in your home directory already. It's a default one, but you can customize it. You can add other things to it. So, for example, if my username is root, if I'm logged in as a super user, I change my prompt to have a number sign in it. Otherwise, I change my prompt to be the command number inside curly brackets. Okay, you can set your prompt to be whatever you want by saying ps1 equals something. So if I say ps1 equals hello, now instead of giving me a number in curly brackets, it says hello. If I set ps1 equal to 3 greater than signs followed by a space, that's my prompt now. So you can set up your prompt however you like. And there's lots of little bells and whistles you can put in here. Okay, I have an alias for QA, which says go into this directory called QA under my home directory. If you don't want to accidentally exit your login session by hitting Control-D, you can set ignore EOF to some number bigger than 0. If I set this to 5, I have to hit Control-D 5 times in a row to log out. Alright, I have GCC set up to a different version of GCC, a GCC with these switches. And so on and so forth. History size, this is where I say I want to remember 5,000 commands of history. Here's this backup command that I use for throwing things into a short backup directory. Alright, so you can put information, you can put basically commands in .bashrc, and those commands get executed whenever you basically log in. Alright, so my prompt is set to 3 greater than signs right now. If I log out and I log back in, my prompt gets set back to what it was. Why? Because when I logged in, it executed everything in my bashrc script, which included setting the prompt to, my command number inside curly brackets. And so yeah, so somebody asked, are ls-a and la the same? So on most of your settings, I believe it is. If I say la, it doesn't know what that command is. But if I wanted la to be an abbreviation for ls-a, I could say alias la equals quote ls-a. And now if I say la, that shows me my directory listing with hidden files exposed. So you can do a lot of customizing to your environment, and you can put those customizations inside your bashrc. most things that you do disappear when you log out. So right now LA is a shortcut for ls-a. If I log back in and I say LA, it doesn't know what I'm talking about. Most of those things are transient. So if you want them to be permanent, put them in your bashrc. And if you don't have any customization you want to do, don't worry about it. Don't worry about bashrc yet. There'll be plenty of things coming up that you will want to customize, and then that will make more sense. Alright, so let's jump into some Linux commands, and let's look at how we can put commands together to do more interesting things. So there's lots of commands for finding out about your environment. So for example, if I say uptime, it tells me how long the system has been up. Okay, I rebooted it a few weeks ago. Normally this is up for about a year before I reboot it. It's not unusual to go to some Linux systems and see that they've been up, for 5 years or more without a reboot. So the system's been up for 19 days. There's 14 people logged in. Okay. It's 10:30 in the morning right now. Load average tells you how heavily loaded the system is. A load average of 0 means there's really nothing going on in the system. The higher this number is, the busier the CPU is. When this gets up to about 3 or 4, things are pretty busy. If it gets up to 7 or 8, something major is going on. And I believe this is a 5-minute average, a 1-minute average, and a current, but I could have those backwards. I think it's current, 1-minute, and 5-minute average. I don't know. You'll figure it out. So it's a quick way to kind of see how busy is the system. If things seem really slow, you can do an uptime, get an idea. Another command is top. And top shows you a running display of what's going on in the system. And so there's my uptime information at the top. 204 tasks, 1 task running, most of them are sleeping. Okay, they're waiting for stuff to happen. What's the 1 task that's running? That would be the command top. Right? Because when I'm looking at this display and it's actually executing this, if this is a single core system, there's only 1 command executing at that particular instant, and that's this command, top. Everything else is hanging out. Awesome, lots of people trying top. No stop jobs, no zombies. We'll talk about zombies towards the end of the course when we talk about processes. How much time is being used by different parts of the system, synopsis of memory, and then lists of jobs from most CPU intensive on down. And you can see most of the time the system's just idle, right? So our load average is creeping up a little bit, which is cool. But, CPU is really not doing a whole lot. Alright, df is a command that shows me information about the file systems, the places where we store information. And this is the main physical drive, is just slash. Remember, there's a file hierarchy. It starts with slash. Everything is a subdirectory of slash. And slash has about 38 gig available on it. So these numbers are in K. It's a 50 gig partition. We're using about 9, and it's got about 38 left. So we're using 20% of it. And you can do this on your own system, right? And see what your home system looks like. So my system, right? I have a 250 gig main partition. That's my super fast. I forget what it's called, but it plugs in through the PCI bus, right? So fast solid state drive. I have an external drive mounted. This is a 2 terabyte partition. This is sitting on a box under my desk. Yeah, NVMe, thank you. It's the really fast kind of solid state drive. This is an external partition sitting under my desk that I have backups going to automatically. and this is a more generic solid state drive that I put most of my stuff on. That's a terabyte. And you can track this over time, right? If you're worried about disk space and so on and so forth. There's a command called watch. If I say watch and I put a command after this, it will execute that command periodically. For example, if I really want to know what the load average is doing over time, yeah, I know I can run top, but I could also say watch uptime, and it will run this command every 2 seconds and update it for me. So that's not very exciting. We got a few characters changing, but we can do that. We can say watch df, and it will show me my disk usage. So if you're doing something, hopefully not on this server, that's chewing up a lot of disk space and you want to track that, right? Watch can be a useful command. ifconfig shows me my network status. iwconfig, that's not installed. But I can say watch ifconfig, and I can monitor what's going on my network, right? So in particular down here I can see how many packets I've received and how many I've sent, and total number of bytes received and sent, right? And I can, you know, track that in basically real time. So watch is a really useful command. And I'm getting out of it by just doing Control-C as usual. Alright, ls we know about. ls shows us the contents of our directory. wc, word count. So I'm typing in some text, okay? When I'm done typing in text, I want to signal end of transmission. That's a Control-D. So I'm holding down Control, hitting D like dog, and the WC program prints out 3 numbers. First is number 3. That tells me I had 3 lines of input. The next is the number 6. This is a test, hello, goodbye. I had 6 words of input. And then 30, that's how many characters it saw. So I can type WC and I can type, you know, whatever I want. And when I get to the end of my input by hitting Control-D, it tells me how many lines, how many words, and how many characters. Okay, why is that useful? Well, for example, if I say ls, I can see how many files I have in my directory. I can connect commands together. I can say ls, and normally that will show me information on my screen, but I can say instead of showing this information from the ls command on my screen, let's send that information to another command. So we can use something called a pipe. And the pipe is represented with a vertical bar, and I can say take the ls command and pipe the output of that into the word count command. And when I do that, I'm going to see the following: 53, 53, 447. That 53 is going to tell me I have 53 files in my current directory. We did the who command yesterday to see who was logged in. If I do who and I pipe that into word count, I don't see the output of the who command. It goes into word count, and word count counts how many lines there are and says there's 17 lines. Well, that tells me 17 people are logged into the system. So we can start putting commands together. And by learning a small set of commands, but thinking in terms of how can these be combined, we can do a lot of really powerful processing in Unix. Now there may be a switch I can put on ls that tells me how many files are in my directory, but if I know how to do this piping business, right, I can take ls, pipe it into word count. If I do ls-a, pipe into word count, I see that I've got 80 files if I count the hidden files. Alright, another command is called grep. Grep is a search command. And the way this works is you say grep, and then you put in some pattern that you're looking for, and then you can optionally put in a file name. If you don't put in a file name, it just searches its input, right, for the given pattern. So if I take my a command and I pipe it into grep, I can use that to search for specific things in the output of that command. For example, if I want to know what Nick is doing, I can say, let's do the who command, pipe it into grep Nick, and it will show me anything produced by the who command that has the word Nick in it. ps-elf will show me information about every process running on the system. If I want to know details about certain processes on the system, for example, I want to know all the processes owned by root, right? One way to do that is do a ps-elf and just search the output for root. And now it's only showing me anything that has the word root in it. So mostly I got processes owned by root, but you notice I also picked up this one line down here, which was owned by Nick, but I was executing the command grep work, grep root. Right, so that got picked up. All right, so grep can be pretty useful. ls-a shows me all my files, including the hidden ones. And grep will understand more than just a pattern of characters. And we'll spend a few days talking about what are called regular expressions. That's the REP part of grep. But regular expressions are ways to basically provide patterns that we want to match. And so suppose I want to know any hidden file in my current directory. I just want to see a list of just the hidden files. I can take a list of all the files and I can pipe it into grep, and I can say, let's look for this funny thing, !period. Well, that's how you tell grep you want something that begins with a period. So if I do that, I get a list of all my hidden files. And if I put that into word count, I can see immediately I have 27 hidden files in my directory. So instead of trying to memorize, thousands of commands, it can be useful to memorize a small set of commands that you get very familiar with and that you start putting together in clever and interesting ways. So I'll show you a few of the most important commands on the system. One is called fortune. You learn to write as if to someone else because next year you will be someone else. I'm not sure what that means. But fortune gives you, a daily fortune. There's actually a version of fortune called AskKhan, AskKhan, which was written by a student a few years ago. And he liked the fortune program, but he made his own version that used fortunes that he thought were appropriate for CSE224. So they're more programming oriented. So fortune can be fun. Another command is cowsay. So I can say cowsay hello, and I get a picture of a cow saying hello. All right, so can we put those together? I can take fortune and I can pipe the output of that into cowsay, and now I have a cow giving me a fortune. So how do you stop an elephant from charging? Take away its credit card. Classic. All right, date tells me the date. If I take date and I put that into cowsay, I can have a cow telling me what the date is. All right, so those are good to know. Alright, another thing we can do is we can redirect the output of a command into a file. And we do that by typing in the command name, but then saying greater than sign and file, a file name. So for example, if I say print working directory, it tells me what my current directory is. If I say print working directory greater than, my file, I don't see the output of my pwd command. It was redirected into a file, and now if I look at an ls, I have something in here called my file. And if I look at the contents of that, it was the result of my pwd command. If I say date and I put that into my file, now my file has the date in it. And you notice that that date does not change. Okay, it's not running the date command anymore. I ran the date command once right here and captured the output and put it into a file. But that file is just a bunch of text now. So I can take the date, I can pipe it into CSE, I can redirect the output of that into my file. And now if I look at my file, there's my cow. And I can even VI it, because it's just a plain text file. So pipes in a way are kind of like output redirection, because we can also do input redirection and say, instead of reading the input from, say, the keyboard or from a pipe, read your input from a file. So if I want to see how many files I have in my directory, here's what I could do. I could do ls and send the output into my file. And it doesn't have to be called my file, I'm just picking on it right now. So my file is, this big long file with all of my files in it. And now I could say, let's run the word count program, but take the input for that from this file. There's our 54. Well, that's exactly the same thing as doing just ls and piping it into word count, except I got, this extra file in the middle of it. But that's basically what this pipe does. It takes the output of this, it sends it to the input of that. Alright, so yeah, ODP 401 to cow saying hello world. Unfortunately, it would give you 0 out of 10. But it would be a far superior program and probably worth a 10-point loss. Because yeah, style counts. And you can put CSE in your bashrc, right? And now every time that I log in, I'm gonna have a cow telling me hello. Well, what could be better than that, right? Okay, cool. So somebody asked, can you do SL and put that into CSE? That gets a little wonky. But give it a shot. So SL is an interesting program. If we take SL and we redirect it to a file, right, we don't see anything on the output. If I try to cat that file, I actually will see my steam locomotive, but it'll be really, really fast. Because SL actually displays this to you with a time delay so that you get a nice visual effect. If I edit that file, it's got a bunch of strange things in it, right? Well, you can see pieces of a train. But all of these things that start with my blue caret square bracket, those are escape codes. And those are telling my display to do things like change the color, move somewhere, or things like that. And right, yeah, so vi.bashrc to edit it, And for me, I just went down to the bottom and I just added my cowsay command. I don't remember what that last file was that I just created. I can say ls-lrt. Oh yeah, it was called output. So I can get rid of output now. Alright, so we're out of time here. Play around with those, do your ODP, make sure that works. Let me know if you're running into issues. Remember, try to show me as much information about your assessment as possible. And I will see you all tomorrow. Thank you.